once again. Nice to see you here. I hope everyone enjoyed yesterday welcome drinks. So today is an intense day, and I will start with the main thing, which is SprutCAM X presentation. But before I will show you the new features and the new interface of the new software, I would like to say thank you all for coming, because coming here, you're showing us that you are making your contribution to the common sense, you're thinking about the future, you are showing that you are interested, and we appreciate all of you here, guys. Thank you. Okay, our team was working very hard for the whole year to make today's presentation possible, and we invested huge amount of time into the new version of SprutCAM. And here are some numbers. So by now, SprutCAM contains more than 3 million lines of code. We have all in all around 18,000 unique users. For the year, during the last year, we had 810,000 of launches. Okay, we are going to 1 million, I think, for the next year. We had new trial licenses in amount of 13,000 and more than 2,000 of new commercial licenses. This is the numbers for the year, for the last year. And God only knows how many Jira tickets we closed, guys. These guys are sitting here, who are working on tickets. Okay, during our year, we not only made software development, but we also made a huge job in terms of marketing. This is something new for us. And we managed to develop a new marketing strategy, which will be executed and will be reflected in the new marketing materials, which I hope you will receive along with the release version of SprutCAM X17. This is how now we position the software. The main product, SprutCAM X, is a CAD/CAM software for next generation makers. And as it comes to SprutCAM X Robot, we realized that we have literally no competition in the area of robot milling, and taking into account all other applications of SprutCAM X Robot, which are welding, additive manufacturing, trimming, painting, and so on. We now position SprutCAM X Robot as all-in-one CAD/CAM OLP for robots. Okay, before I switch to the new version, I would like to share a really important topic here, is the interface, is how users perceive the product. In terms of this, SprutCAM X went a long way. We spent a lot of time exploring into how people actually use software. We collect usage information. My colleagues will share you some numbers today, you will see. We also observe how people start using SprutCAM right after training. This information always was a huge foundation for us to create a proper user experience. And here are the principles of the interface design. In theory, it sounds very easy. Literally, less interface is better. It's very easy to say, but very hard to do, especially when it comes to CAM software with hundreds of features. I'm sure that you all have seen many times some typical CAM software with 300 buttons just on the main screen. We believe that SprutCAM UI is a huge selling point. We believe that good and lightweight UI makes it easy to sell. And during many years, we were doing our best to keep the UI as simple and as light as possible. By the way, here is the evolution of SprutCAM interface, starting from version 4. We did not manage to launch the previous versions on the contemporary PC, but I think there is Ragazzi Italiano who can show you. Okay, during the years, we were holding our principles. You see that we have evolutionary changes from version to version. And during last couple of years, we made the next step to make it not only lightweight, but we also started thinking of how naturally and comfortable does the human eye perceive the colors. And in version 16, we introduced the colors which were inspired by nature, We took colors from the sea, the sun, the sand, the rocks, the ground, and put these colors into the interface in a balanced ratio. So let's speak about changes a little bit. Sometimes we have to admit that it's quite hard to accept the changes. People don't like changes, okay? But after a certain period of time, it turns out that changes are good, actually. So in order to accept something new, people have some frustration first, but we expect from you to be on our side here and help our users to accept the changes. Because sometimes a person who is facing with something new interface, new features, new workflow, he needs some support from the dealer of SprutCAM, who will explain him that actually the new things are good things and help him to overcome this denial and frustration stage in order to proceed to integration stage. So after the integration stage is here, the person can compare before and after and instantly understand that new is better. But it's not obvious from the first trial, first period of time. And we also help our users to accept the changes. For example, with these new nice smart hints you have seen in version 17, which are very lightweight, easy to use, intuitive, and interactive. And they are helping our users to navigate through hundreds of technological parameters we have in operations of SprutCAM. So now let's take a look at the version 17 interface. We did not make any revolution. We made evolutionary changes. We made even better color balance for long work because our users spend a lot of time in front of SprutCAM window. And we also went in depth to provide consistent interface in various second-level windows. Briefly, these are the windows that we reworked, not all of them, only part of them. I will not show you all of them now because it will take until tomorrow lunch maybe if I start showing you one by one. But you will be able to see all the changes when you start working in version 17. Okay, and this is our vision of how the future of CAM software can look like. So we always keep experimenting, and we have now we have a very strong UI UX team, and I'm sure that we will keep CAM X interface at the highest standard that we set for ourselves many years ago. Okay, now let's go to the features. I think you're all waiting for that. Okay, and first I will show you some features which were made in the platform, so they are facing all users and changing a little bit, involving all users. And the first one is the multi-project workflow. Okay, let me show you. So this is version 17. You see it on the screen. Okay. So now I can open several projects in SprutCAM, switch between them. So, and working as usual, I can also split it into two windows if I have multi-display workstation and work on two displays simultaneously. I can bring them back like this. What else I can do now? For example, I can switch to the project, run the simulation, run the toolpath calculation, switch to another project, and while the first project is calculated, now I can work with another project as usual. We believe that this is a huge time saver, making our software more time efficient, because time is something we are fighting for our users, and this is maybe quite a straightforward thing, but it brings quite a big change. What else can I do with the multi-projects? For example, I can take some operation. Let's stop the toolpath calculation. Okay, I can take some operation, copy it from one project, switch to another project, and paste it to another project. Okay, it's a quite simple thing, so I will not spend a lot of time here. You will experiment yourselves. Okay, switching back to the presentation. Okay, so the benefits of multi-project workflow is a more streamlined workflow for time efficiency, and it will help to reuse the approaches from project to project to also to save time for people spending less time into configuring the parameters of the operations. Next hot topic, guys, the undo. Where's the undo? This is a question you were asking for many years, I think. Yes, unfortunately, undo as it is in text editor, for example, is not possible in CAM software from our point of view. Sorry for the disappointment, but actually we made snapshots, which is how we call undo. It's not undo, it's something more than undo. We, let's say, reinvented undo to make it even better. It is similar to undo, but more corresponding to CAM workflow from our point of view. So let's take a look. For example, I have let's switch to another project. So here I have the project, and now if I navigate here, I see the snapshots. Okay, so the snapshots are saving the state of the project at a particular stage. Currently, we are making automatic snapshots before and after the user is pushing this run button. And for example, if I accidentally delete the operation, I can always go to the snapshots, see snapshots before deleting the operation I have just deleted, push it, say no, I don't want to save changes, and here I have it back. So what else do we have here? If I open Snapshot Manager, I can see all the snapshots I have in the project, okay, with the screenshots and with the operation list. So it will be easier to navigate through the snapshots with the Snapshot Manager in order to open the desired project state. So nothing complex here, quite easy, but I think it's also, it was a highly anticipated thing. Okay, so as for the snapshots, we believe that our users will now benefit from enhanced safety while working on the machining project, and of course swift restoration of the desired project state if something goes wrong, and something goes wrong from time to time, you know. Okay, next we introduce machine setup file. Machine setup file is also something we made for making our workflow more time efficient. So machine setup file is something that you can save and load in order to make projects with typical parts when you have the same tools, the same machine, the same setup information, and you need just to make another part with another toolpaths, and you want to save time for configuring, for example, your double turret mill-turn machine. Okay, and there is also one more reason why we introduce machine setup files, which I will show you today later. Okay, let's check what we have for machine setups. Let's say I have a project with a mill-turn machine. Okay, some turret loaded with tools, the machine set up somehow. Two setups here, okay, with part turnover. Now I can save as machine setup, okay, have a file, and if I start a new project with the same machine, now I can import the machine setup, this one I saved before, okay, and now I have all my tools loaded, all my setup stages here, and I'm ready to make another part. Okay, this, for example, let's make some small like example. Okay. Okay, here I have the part. So I can adjust the setup, of course, if something has changed, no problem. And also, yeah, okay. No, not also, but okay. Now I can create the operations now, and the tools which I already have on the machine I used for this project. So you don't need to reconfigure or to configure from scratch. You don't need to save your like empty projects anymore. Okay. So let's take the benefits. Take a look at the benefits. So as I already told, the machine setup files are for easy and quick transfer of machine digital twins, settings, tools from ready-made template. They contain the machine, the machine setup file contain the machine, fixture, tool list, tool blocks, tool positions in the turret, machine dimensions, auxiliary equipment status, and setup stages and parts from a SprutCAM project. Basically, it's the SprutCAM project, but without parts and without toolpaths. That's it. Okay. Next topic is the machining report. So let's be honest, guys, machining report was not the strongest point of SprutCAM X until now. But we made a total re-engineering of machining reports, and now we can say that we bring them to the appropriate level. So I will not show you the machining reports right now, but you will be ready to test it yourself. So now we're featuring easy to configure templates and PDF export and all of the flexibility of typical SprutCAM workflow. Next thing I want to show you and I want to talk to you a little bit about is the AI assistant, which we introduced in version 16 a couple of weeks ago, I think. Okay, I know that it's a hot topic, but we are sure that the deep integration with AI is the future of CAM software, and this does not depend on our opinion on this. Okay, it will happen inevitably. And we made this first step in this topic, introduced our AI assistant ENCY. And for now, it's quite simple, but still helpful AI assistant, but it's only the first step. So let's take a look at the demo. By the way, who tried already something? A few people, yeah, here. Okay. That's good. So I will open a simple project. So here I have some operations, particularly drilling. If I go to post-processor, apply some numeric post-processor for this operation, this only operation I'm going to post-process. Here I have ENCY code, and let's say I'm not a very experienced CNC operator guy, and I want to understand what's happening here. Maybe I see the numeric code for the first time in my life. Okay, so I can just select some code, press this button, and ask ENCY to explain me what is happening, what is written here, literally. So it will take some time. Okay, now we have a reply. If you, by the way, if you put your own API here, it will work faster, and we believe during next months it will also be working very fast. It's just something which is developing very fast. So now we have our ENCY code with all the explanations of what is happening. We think that at least this is something which is ENCY can be used for right now already. Okay. In brief, the AI is not less than introducing the revolutionary CAM changes in workflow, in terms of workflow. We believe that this topic will be the #1 during, I think, next year, maybe next years. And with releasing the AI assistants, we showed to the whole CAM community that we are at the edge of technology. We're making it first CAM software with AI assistants. And we sure that also, for example, for learning of G-code or learning of CNC machine programming, it could be also a huge assistant, huge thing. Okay. And so maybe for the last 15 minutes you've been waiting for some technological updates, some toolpaths, asking yourselves, where are the toolpaths? Where are the new toolpaths? And we are 100% sure that version 17 is the most powerful version technology-wise of SprutCAM X by now. And let me introduce my colleague who will show you what is under the hood of the new version of SprutCAM X17. Please welcome senior SprutCAM X developer, PhD in mathematics, Mr. Alex Groshev.
Okay, I'm really very happy to see all you here. Most of you I know many years, and today again I meet all you, and I'm very happy because of it. And before I start to present the new features of SprutCAM, I would like to demonstrate you this diagram. These diagrams show the frequency of operation usage by SprutCAM X users. As you can see, top 4 of 5 operations are free access operations. Free access operation is the basement of any CAM software. And in version 17, we pay special attention for these free access operations. So you can see that the first 2D contouring, roughing waterline, holes machining, face milling, and only the thief operation is 5D surfacing. Okay, the first feature I would like to demonstrate you is improvement in the roughing waterline. I think you know the problem that the step is more than 50% of the tool diameter. We have unmachined areas, and in the in the left side of the screen you can see what we had in version 16, and in the right side you can see what we have in version 17. Let me demonstrate it. I just open the projects. So this is simple part, and it is calculated in version 16. And if we go to simulation and run it, you will see unmachined areas. The step of machining is 80% here. So this problem must be resolved maybe 20 years ago, but it's better later than never. Okay, so just right now I will recalculate the toolpath, reset and run. Nothing changed, and we can see these lines. And so right now if I go to simulation and run it, toolpath is perfect and there is no unmachined areas. I think it's very important, and all users understand how important is it. Okay. Benefits. So the calculation of roughing waterline in version 7 is faster, maybe 30% is faster. Toolpath is better, and also simulation highlights different problem zones, so it's much safer right now. It's I think you will like it. Okay, the next feature I would like to represent you is it's again about free-axis milling, and it is undercut waterline. Undercut, it's new operation, and let me demonstrate it. So we will see, or we will machine this STL model, and the problem of the difficulty of this model is that there is the places in this area that the end mill cannot reach, and so let me delete this operation. Oops, let me delete this operation, and I just want to say how is it easy right now to machine this. Create run 5D advanced undercut waterline, new operation, and go just and select the tool, this one. Okay, and the difficult zone, it is here in this area, and just click run, and calculation is fast. It's modern operation. It use all cores of processor for the calculation, and let's go to simulation and check the result. Ready. So it's a next improvement, and the main benefits of this operation, it's allow us to use specific undercut mills like lollipop, disc tools, etc., and it's very simple to use. Okay, it's about undercut waterline. And the next topic I would like to demonstrate, it's also new operation, now not for 3D milling, point pick and place operation. This operation was developed to move the object from one place to another one by robotic arm. Now you can create any count of nodal points in this operation and move the end effector through these points. Let me demonstrate it. Okay, so in this project I will machine this assembly. Assembly consists several parts, 6 parts, and we will assemble this object right now in SprutCAM. So if I go to machining, we can see, okay, disable the path visibility. We have 2 robots in the cell. The first robot is equipped with a gripper. The second robot is equipped with a welding torch, and we have also positioner with vices, and we have the parts that are located on the table initially. So just run the simulation. Just run the simulation and click play. In the beginning, the first robot take the first part. We control the grippers, so commands to control grippers exist in the command. Okay, vices visibility, I will add it. Okay, it moves part to the vices, close vice, open, and go and take the next part. Take next part, attach it to the first one exactly in this position. After that, second welding robot start and weld it. Okay, so And right now, let's continue to do it several times. Robot, again, take the next part, move it, attach, welding. Take, move, weld. Take, move, weld. And the last part, again, attach here and welding in 2 points. This one and this one. Okay, collision avoidance work everywhere, so everything is green, you don't see the collisions. And few words about point, pick and place operation. The main changes in the job assignment. Job assignment contains nodal points. We can add any nodal points we need, and tool will go through these points. That's about point, pick and place. And what is the main benefits of this operation? The main benefits is that we can create totally new kind of projects. So right now we can create so-called assembly projects. It's not a mechanical machining, it's assembly projects. Okay, the next group of features I would like to demonstrate, it is about redundant access optimizer. I understand that users who already programmed robots with SprutCAM know what is it. And the first feature is possibility to control arbitrary machine parameters. What is it? We added the special parameters in machine schema that can be added to the axis, and if this parameter is enabled, then we can control it. Let me demonstrate it. Okay. I would like to say special thanks for these projects to our Chinese dealer Chen Chen. Okay. Here we cut off the simple automotive part by laser. The first operation cut off the inner holes. It's not important here. And the second operation cut off the outer profile. Toolpath is quite complex, but what is interesting, it's about these clamps. If we look at it, so when it goes to clamp, so clamp open, go away, after that clamp close. Next, clamp open, close, open, close. So how it was done? Honestly, Sprut technology did nothing to make it. It was totally made by Chinese dealer. And how it was done? First of all, in the machine schema in lines, we have the axis, machine state parameters, clamp 1, and these parameters is enabled here. Clamp 1, clamp 2, clamp 3. It is described in machine schema. After that, in the second operation, if I open the map, we have the tabs. Clamp 1, clamp 2, clamp 3. Okay, let me move a little bit. So this clamp, it's open and close. So if I want to open it early, I can just move. I can just move it here, so it will be open early and close. And this graph is done for every clamps. So it will be output to the toolpath, and you can analyze it in the post-processor to generate some comments. Okay, it's about arbitrary parameters. The main benefits of this feature that we get the possibility to control and simulate any parameter. The meaning parameter can be any. It can be voltage, it can be current, it can be feet of paint or material, anything you want. You just draw the graph, and these coordinates that you draw on the graph go to toolpath, and you can analyze it in the post-processor. Okay, and okay, the next feature for robots, it's the boundaries of periodic axis right now displayed on the map. What is the periodic axis? For example, the joint 4 and joint 6 of the robot has the range from minus 360 degrees to plus 260 degrees. So it can make 2 turns. And in version 16, we cannot check the limits of this axis. So right now it is possible, and these new lines that you can see here exactly show the limits of this axis. Let me demonstrate it. Again, Chinese project. Okay, what we can see here, hanging robot, and it cut off by laser cutting closed profile. Closed profile, quite complex. And if I calculate toolpath right now, we will see the error here. Yes, we will see the error here. And let me open the map, what we can see. Okay, on the map you can see these new lines, and the map legend is shown here, the colors. So minimum and maximum of joint 1, 3, 4, 6. And in the bottom there is the verification, collision, and we can see one overturn. For example, this overturn is generated exactly. Sorry, there is a point, it is located here. Maybe it's not visible, but it exists, believe me. Okay, and so I can, for example, edit the graph here. So verification says okay. I can update toolpath. There is no the other turns right now, and let me maybe add the collision avoidance for approaches and returns, and we calculate toolpath. So go to simulation and check. Toolpath is really complex because robot is hanging, and it starts here, moves. Okay, toolpath is perfect, everything is green, there is no collision. So it's about improvement in the map. And so the main benefits of this feature save the time on programming and avoid the overturns. And so that's all I wanted to say about the axis optimizer. There is one more additional feature, but I will not show it right now. And the next feature I would like to demonstrate you is improvement in the approach rules that is very actual for the TCPM machines. Okay, it's right now it's it's possible to generate the approach in the coordinate system of the first point of toolpath. Coordinate system of the first point of toolpath. Let me demonstrate it. I open this project. It's actual for 5-axis machines. So in this project we have 5-axis machine, and we machine this gear right now. And let's check the approach for the second operation. Open approach. So right now we can see that the first motion, it rotates axis A and C. After that it goes axis Y, and we can see the huge number, and this number is in wrong coordinate system, and we would like to avoid this number. And after that there is the comment that enable the TCPM mode. So if you know, TCPM mode is activated, for example, by command M128 for iodine, Traore for cinemeric, G43.2 for FANOC. I hope you understand it. Yes, and I would like to avoid this coordinate, and what I have to do, I go to machining, open the approach rule, and here is the approach rule for my operation. I delete it and type the new, input the new rule. First of all, I would like to move axis A and C. After that, I write the special command SLCS, start local coordinate system, and in the brackets I type XY and Z. So this motion will be performed in the, so it's located in the brackets, and it will performed in this coordinate system. So let me calculate the toolpath. What we can see right now, the first motion is rotating axis A and C. After that, let me make visible it will be better. So after rotating, the origin is stay outside of the part. After that, we activate origin, rotate, activate origin, and origin goes to the first point of toolpath. After that, we go x0, xy0 in the coordinate system. In this coordinate system, tool goes here, go z, and after disable coordinate system and enable TCPM mode. After TCPM mode, we can see origin is here. So with this feature, it's much easier to generate correct approaches for the 5-axis machines in TCPM mode, and this feature was developed by a request of our Poland dealer, and I think it will be very useful for another dealers who sell SprutCAM for 5-axis machines and use it. Okay. Benefits. Okay, it's just safe. And the next feature I would like to show is solid simulation. You know that in SprutCAM we have two modes for the simulation. Voxel mode, it's very fast, and there is another solid mode. Solid mode is high tolerance and very good, and right now in version 17 we can simulate 5-axis motion. 5-axis. In version 16 we can simulate on 3-axis motion, and let me demonstrate it. I will use the same project. I will use the same project, disable machine visibility. It's not actual here right now, and tool holder also. And in the beginning, so right now we have type of simulation is voxel 5D. And let me start with simulation. So, and very fast results, and let's check the quality of the part. So we can see its tolerance is enough, but it's not really perfect right now. And here is the resolution of voxel, and it's for example for the cases when the tool size is much less than the workpiece. For example, wire EDM or laser cutting. For example, we have huge part and laser diameter is less than millimeter, and the size of the voxel can be less than the size of the tool. So this voxel simulation cannot be used. Let me change the simulation mode to the solid and resimulate it again. It's little bit slower, but already right now we can see that the quality is really perfect, And the next, okay, let me check, make it slower. So okay. Not my mouse, sorry. This one. Really very high quality. Let me continue to the end. And what we can see right now, it's really it's high tolerance, high quality. Everything is really perfect. Okay. What I can say, it's really unique technology. I don't know other CAM solutions which offer the same level of simulation technology. I think we are only one in the world who have done it this way. And I already said that it's very helpful when the tool is much less than the workpiece size. Okay, so and now move to the CAD. Okay, most of you already know another CADs, so it's difficult to surprise you, but anyway, first we redesigned menus, windows in CAD Module to support high-resolution monitors. We streamlined workflow. Now CAD design is much easier for new users. A lot of explanations. I recommend you to test it. We improved performance and stability. For example, incremental model updates. It means that when we change the dimension of the model, all the dependent solid, we recalculate only dependent solid. Solids that depend on this dimension. So it's much faster right now. And sure, we fix a lot of bugs. It's clear. We add the new operation fillets and chamfers. We add the new operation draft that allow us to incline the surfaces. We add the patterns that allow us to multiply solids and surfaces. We add the Boolean operations right now. And we improved sketching features. For example, offset command was added to the button. The feature image to trace, we can easily load any image and outline it. And let me demonstrate a little bit. CAD, I will not draw, but I have to say that for CAD, for the main adventure of the CAD integrated in the CAM is associativity. With associativity, we can easily change our part and make the new program. For example, this part was drawn in our integrated CAD, and we have the toolpath. I will not simulate it. You can, okay, you can see it, everything. So right now I can go to model, click design, edit, and for example I can edit any sizes I want. For example, change this angle. Oops. Or take and move this size, or change this dimension, and everything works smooth and fast. After that, I can just go to machining mode, just run, calculate, and we will have updated toolpath for the new part. It's fast and easy. It's really fast and easy. So go to simulation, run simulation. Okay, forget drilling. Not important here. Associativity is very important for the turn milling, because the parts in turning are simple and we can draw it in our CAD, and parameterization is very important here. Let me open another example. Okay, so here, this is the example for the sleeve, for the Swiss type machine, Swiss lathe. Let me disable this model and show you the simulation. It's a little bit not about CAD. After that, I will show how to change the dimension. So we will machine this part, and this part was drawn in the integrated CAD. So right now I just want to demonstrate you the project. Go to simulation, and so run multi-channel mode. Let's run simulation mode and continue. I run simulation, so it machined two parts together, machine parts in the main spindle and the parts in the sub spindle working together. After that, we will machine by these tools synchronized drilling of two parts. Next machine, next drilling. After that, go away and take over. Subspindle takes the part, tool cut off and remove. So it's a little bit simulation of Swiss lathe. And for example, if I want to edit the part, I need just to go to simulation mode, change little bit sizes of the dimension. So after that, I can change any values, for example, diameter of this value or this size. And after that, I can go to machining. For the turning operation, for example, I need to touch job assignment, so we have little bit, and if I draw it, so the profile was updated after that. So after that, I can recalculate toolpath, and we will get the simulation for the part with new dimensions. Okay, let me continue. So my presentation is over, and let me invite Andrei back to the stage. Thank you for your attention. Okay.
Okay, thank you, Alex. So we believe that we are introducing the most powerful version of the best ever CAD/CAM software right now. So let's enjoy with a little wrap up and see the video. By the way, did you notice the great job our marketing guys made? You never saw it before, I think. Okay, you will see more of that during next months. Okay, so the new version of SprutCAM X17 will be available in September 2023.